Hey everyone, welcome to another video. Now, in all of the previous videos in this series, we've been talking about expansion. We looked at binomial expansion, what that means, the types of results we get, and now I want to look at this topic from another angle, and this is through the idea of factorization. Now, we've talked about this previously, this sort of difference between factorization and expansion. Now, we're going to take this one step further because through the lens of quadratics and quadratic expressions, this idea of binomial expressions, binomial terms starts coming up. Now, this is where it starts getting quite tricky for a lot of people. So before we get into this, I'm going to quickly run you through some revision questions, and you can think of this video as a precursor to some of the later quadratic factorizations we're going to be doing in the future. So we're going to start with these two examples, and we're just going to briefly revise. I'm going to go through this quickly because I've assumed you know how to factorize expressions like these by now. If not, I have some videos on this from the previous year, so please have a look at those. I'm going to go through this a little bit quicker. Now, we know that when we want to factorize, we want a term, we want the highest common factor, the highest thing that goes into both of these terms. So I want to find a number or any algebraic expression that is the highest common factor of both 40 and 16b. Now, there's no b here, so we have to just be looking at some kind of whole number, some kind of integer that goes into 40 and 16. And one of those that I can think of is the number 8. Now, 4 also goes into 40 and 16, but it's not the highest possible number. The highest possible factor for both of these terms is going to be 8. So, in order to factorize this, I'm going to pull this highest common factor outside, and the brackets are going to contain what number here was multiplied by 8 to give me 40, and what number here was multiplied by 8 to give me minus 16b. Once again, this is all revision. Hopefully this is nothing new. Now I want to find a number that multiplies by 8 to give me 40. Well, that number is going to be 5. Now I also want a number that is going to multiply by 8 to give me negative 16b. Now this negative is important because that tells us the sign that we would expect for our term down here. Because we have a positive 8, so we would want the number or the term in our brackets to be negative, because two negatives multiplying are going to give us a negative product up here. So I'm going to have a negative here, and we want to find out what was multiplied by 8 to give me negative 16b. Well, 8 goes into 16b 2b times, and my negative remains because I want a negative product. Now, factorization, guys, just tells us what an entire expression was with brackets before it was expanded. That's just some revision from before. Now for this second example, I'm going to go through this quickly again. I want to find out first, before I do anything, what is the highest common factor of 8x squared as well as 12x. Now one thing I can pick up on here is that there is an x in both of these terms. So that's going to be one of my factors. And I also want to find a number that goes into both 8 and 12. Now that one is going to be 4. So my highest common factor, highest common expression that goes into both of these, both 8x squared and 12x, is going to be 4x. So that is going to get popped out in front here. And once again, I'm going to draw in my brackets. Now, I want to find out what was 4x multiplied by to get me to 8x squared. Well, it had to have been multiplied by an x because I have an x squared here. And the 4 went to 8. So it got multiplied by 2. So when I factorize this, I pull out my 4x, and the thing inside my brackets was 2x. Now this next term's positive as well, so I'm going to have a plus here. And I can see that my x remained here. So there won't be another x in my brackets here. There's just going to be an integer to get me from 4x to 12x. So what got multiplied by 4x to give me 12x? Well, that is 3. Because 3 lots of 4x is going to give me 4x plus 4x plus 4x. Adding those algebraic terms together gives me 12x. So that is a quick revision on how we can factorize expressions. But now we want to talk about the thing that this video is essentially about, and that is binomial factorization. So we want to learn how to take out, we're going to be taking out a binomial factor. So this time, from these terms here, instead of just pulling out one number, one term, one factor, the factor we pull out is going to be a binomial. So it's going to be made up of 2 numbers. So this is going to be a bit weird to visualize probably at first. So let's just jump straight into a question. Here I have, let's do it here, 3 outside of x plus y plus x outside of x plus y. Okay, so we want to factorize this. And this is where a lot of students get a little bit freaked out. Now, that may be you, but all I want you to think of is that both of these things here, this as well as this, are products. In the same way that 40 was a product of 8 and 5, and negative 16b was a product of 8 and negative 2b. They both shared this highest common factor. Same thing with this and this. 8x squared was made up of 4x multiplying by something else. And 12x was made up of 4x multiplying by another thing. The same thing is happening here. It just looks scarier. But we can start this off just by looking at some similarities. Do you see anything that is similar between these two expressions? 3 outside of x plus y and x outside of x plus y. Well, they both share this common factor. What's important to know is that even though we don't know what x plus y are, these are algebraic terms, we know that these x's are the same and these y's are the same. So adding those two terms together means that this thing here is the same as this thing here. So these are actually common factors. So I can say here, actually, the highest common factor is, well, there are no other similarities. We can't do anything with this 3 and x, but we know that both terms, 3 outside of x plus y and x outside of x plus y, contain in them a highest common factor of x plus y. This is the highest common factor. Now, we're going to do the exact same thing we did up here. This should not be scary because we're doing the exact same thing. Now, all we want to do is pull out this x plus y in front. Now, because there's two terms, the only difference between what I do here and what I did up here is I have brackets around the x plus y. So instead of, for example, 4x here, I've just put brackets just to signify that these terms are being added. So I'm pulling that in front. And now I want to see in this bracket what was multiplied by x plus y to get me 3 outside of x plus y, and also what was multiplied by x plus y to give me x outside of x plus y. Now, what is implied here? Remember these things outside of brackets. When we have a term outside of the brackets, this is a shorthand for multiplying. It implies a multiplication. So x plus y here, we see a similarity between that and that. What was it multiplied to get me 3 outside of x plus y? Well, it was multiplied by 3. So that is going to be my term in here. So you can hopefully see here, what I have done in this first step is no different to what I did up here, for example. Take this example on the left. My highest common factor was 8. I pulled that out. And then I said, well, what was 8 multiplied by to give me 40? 8 was multiplied by 5. Here I've gone, the highest common factor is x plus y. What was it multiplied by to give me 3 outside of x plus y, or 3 times x plus y? So that thing there is a 3. Similarly, for this next term, my x plus y, what was that multiplied by to give me x times x plus y, or x outside of x plus y? Well, that thing was just an x here. So what I've done is I have effectively factorized this. I've done nothing new from what we've been doing before, but the only difference is my highest common factor now, the thing I'm pulling out, is a binomial. So this thing here is a binomial. Hence the name of this video, binomial factorization. We're still factorizing, but what we're pulling out now is a binomial expression instead of just a whole number or an algebraic term. It's important to know this x plus y is the same number both here and here, because the common pronumeral means that the number is the same. So what's great here is we don't need to know what x is, we don't need to know what y is. All we know is that they're the same. So the addition of these two same numbers give us the same factor, which allows us to pull it out and factorize something. Now let's look at one more example, and then we're going to keep looking into some more factorizations for the rest of this course. Now here I want to factorize 7 minus 2x minus x outside of 7 minus 2x. Now, we are once again looking for a common factor to both of these terms. Something that is being multiplied, which is the same. Well, once again, we can pretty clearly see a similarity between both of these expressions, meaning our highest common factor must be that which I've highlighted. It goes into both of the terms. So my highest common factor is in fact 7 minus 2x. So I'm going to pull that out the front here. 7 minus 2x. And I've just put it in brackets just to show that this is happening first, that I'm treating 7 minus 2x as a term in itself. So now we want to find how many times does 7 minus 2x go into my first term, 7 minus 2x, and my next term, minus x outside of 7 minus 2x. Well, the first one here, at first it kind of looks tricky because it's a bit different to what we've done here, but it actually ends up being a bit easier. Because think about this. I don't know what 7 minus 2x is, but how many times does it, 7 minus 2x, go into itself? How many times does any number go into itself? Well, it goes into itself one time. So we can think of 7 minus 2x being the same as 1 outside of 7 minus 2x. You can write it like this if it's easier for you, but we can just think of this as, well, how many times does 7 minus 2x go into 7 minus 2x? It's going into itself, right? So it's going into itself one time. Now, how many times does 7 minus 2x go into minus x outside of 7 minus 2x? Well, I just want to see what was multiplied by this to give me x outside of 7 minus 2x. Well, I can see my term is going to be negative because I have a positive thing here and a negative up here. And it goes into it minus x times. Because once again, guys, this is like saying x times 7 minus 2x. This is like saying 1 times 7 minus 2x. So what's important to take away here is that we are approaching this the same way that we've been doing before. This doesn't need to be that scary because although we have binomial terms now, they are still the same. So this thing here, 7 minus 2x, is the same as this thing here. So we can take it out as a highest common factor. And if you look, this example and this example are in fact no different to how we approached the revision examples. We just said, what's the highest common factor of both terms? We pulled it out and then we tried to systematically find out what each of the terms in the brackets needed to be. So we approach it in the same way. And this is how we can go about factorizing expressions with binomial factors. And this skill that we've now learned by the end of this video, this is going to help us when we apply what we know about factorization towards quadratic expressions. Thank you so much for joining me, and I'll see you in the next video.